I think we're going to be just doing a quick run through of a few of the student engineering projects here at the University of Melbourne. My name is Neil. I'm representing Ares Rocketry, so we're the team that's built the rocket here, and following on we'll be hearing from Melbourne Space Program as well as the University Rover Team. To get things started, I'm just going to be giving a quick walkthrough about our rocket here, Florence. Let's go onto the page. Just a quick little recap on what Ares is for those who are here who don't know about us. So we're a student engineering team based out of the Faculty of Engineering and IT at the University of Melbourne. We've been operating since, founded in 2019, but realistically because of COVID, 2021, 2022. We're now very proud to say we're a 90 plus, almost 100 member strong team. We design, build and launch high-powered rockets like the one you see before me, both in Australia and overseas at competitions. When we look at student rocketry, you may ask, what are we doing and what's the point of it all? At the end of the day, as with any of our student engineering clubs, the goal is to educate the future leaders and the future engineers of industry, both in Australia and who will be going all over the world. So at the end of the day, I just want you to think about drawing it back to these experiences aren't necessarily, build the best technology or the most cutting edge things, which we, sometimes do and we can achieve, but it's really about that experience for those engineers and those learning opportunities. So a bit of an overview about Florence. So Florence here is our 3.1 meter long rocket that we built. This is our third competition level rocket that we took to the US, and this one right here flew in the deserts of New Mexico just a couple months ago. It used a O-class motor, which means that it has about 20,000 Newton seconds of impulse, which propelled it to an altitude of 29,782 feet. Now, the interesting part of this competition is that, it's not about how high you can fly or how fast you can go, but it's about how close you can get to 30,000 feet. We want to get exactly to 30,000, not go over and not go below. And just for you, that's around the height of a commercial aeroplane. We are very proud to say our actual apogee was 29,782 feet. That is about 0.6% off our intended apogee. The way we achieve that is we have these air brakes that slide in and out of the rocket that slow it down as it's getting to that final apogee. And so that's just a quick overview. We can sort of start the front at the top of the rocket there, or the forward end. That's all of our avionics and flight computers, all redundant GPS, redundant charge deployment. When we get to 30,000 feet, we've obviously brought it back, and the way we do that is we eject parachutes. So these parachutes, we eject a drogue chute that brings it down to about 1,000 feet, and we deploy a main chute, and that brings it nice, a soft touchdown. We go collect it in the desert. Those computers that fire those parachutes, we've got dual redundancy to make sure that, if anything goes wrong, it'll come out. Below that is a recovery bay, which carries those parachutes, and below that, we actually have a scientific payload. As part of this competition, they want us to develop, like all rockets, the purpose of rockets is to deliver payloads to space, and you'll be hearing about what some of those future payloads might be. For our scientific experiment, we had a 3U CubeSat, and you'll just find out what CubeSats are in a second, but we had a Raman spectroscopy experiment, which was using light to investigate the growth of cells and the death of cells in high acceleration. So what we did is we miniaturized about $10,000 worth of laboratory equipment into a tiny rocket that was able to detect the presence and existence of cells during and what happens to them during high acceleration. Below that we see our air brakes, and those are things that control in and out. We also have a GoPro in there to get some cool footage, and then we have our motor and then the fins. So how did we do? We're very pleased to say we actually came second in our category. We got some of the highest points, and we actually came first for design and build. We came third in that payload category, and fourth overall, so out of 152 other teams from around the world. So the 152 teams all congregate in New Mexico, both from Europe, Asia, Australia. Obviously, a lot of Australian teams, and a lot of Australian teams do really, really well. But yeah, so that's a shot of Florence. At that point, it was just taking off, experiencing about 25 Gs. Maximum speed was about Mach 2, about 1.8, about 2,000 Ks an hour. So it took about 40 seconds to get to the top of its intended apogee. So that's a brief little talk about Florence. Please come and ask questions. And that's us there standing on top of a mountain in New Mexico. That was about 12,000 feet, that place where we took that photo. So really high altitude, which helps us even get higher up. The base we take off from is about 5,000 feet. Follow us on Facebook, Instagram, LinkedIn. We're posting about what we're doing, what we're working on in the future. Really excited, currently working on developing and designing our own rocket engine. The rocket engine here we bought and installed, and we're looking into developing our own future propulsion systems, which will take rockets to beyond 100,000 feet, even to 100 kilometers. So anyway, thank you so much. I'll hand it over to Tori from MSP.
Awesome. Hi everyone, welcome to the Space Showcase. My name is Victoria and I'll be running you guys through what the Melbourne Space Program is and how we're furthering the space sector in Australia. So the Melbourne Space Program is a student-led non-for-profit team established in 2014, and we are currently running 3 long-form projects by the names of Humanoid, Acrux and Animatronics. Animatronics is a project where we're developing an animatronic pet by the name of the Dino or the Quokka. And this is to interact and entertain children in the hospitals so that they can go into the waiting room and have something to do. And the Humanoid project is where we're developing a humanoid bartender with chatbot and computer vision capabilities. I'm the project manager and the co-lead of the Acrux team, and today we'll be focusing on Acrux as the main link between the space sector and the University of Melbourne and MSP. The main overarching goal of the Melbourne Space Program is to develop and foster the next generation of technology pioneers. MSP provides a method for university students and alumni to undergo professional development and gain experience in a field that would usually be out of reach and way too expensive for someone to do alone at home. I'll share with you all a quick testimonial from one of our MSP alumni who said this. My involvement in MSP has been the most profound experience of my life to date, and it's provided life-changing impacts in my education, career and self-identity. So in seeing that, we can see that there has been some success in our team. And it's fair to say that our mission has successfully built up students and made a real connection and bridge between us and the industry. Cool, so now let's get into the nitty-gritty of what we actually do in Acrux. The goal of the Acrux project is to create a family of successful CubeSats. And for those of you who are unaware, a CubeSat is a very small satellite that is usually deployed into low Earth orbit to circle Earth. Acrux is the flagship project of MSP, and it's the reason that MSP exists today. Since our humble beginnings in 2014, our first CubeSat named Acrux-1 was sent to space in 2019, and we successfully established two-way communication with it. 70% of CubeSats failed to reach this point, so this was a huge success for our team, who spent years crafting the CubeSat from the ground up, alongside huge achievements like establishing connections in the industry and securing funding for our team. Furthermore, this was an amazing achievement for Australia, as we were the first team in 45 years to do this as a student team, and that was since the Australis Oscar 5 CubeSat. So since Acrux-1, we've been working on a bigger and better project that we surprisingly call Acrux-2. Our mission statement is to be the first Australian student team to develop a satellite to take a photo of Earth from low Earth orbit. Acrux-2 is going to be 3 times larger than Acrux-1, standing at 100 by 100 by 300 millimeters in size, as you can see up there. And Acrux-1 is currently sitting on that table down there as a little comparison. We're developing a lot of our own technology alongside some off-the-shelf components that we're currently integrating ourselves. And the most exciting addition to this new Acrux is a camera that we will be able to control from the ground here in Melbourne to take photos remotely from space. Communications will also be directed through our in-house ground station that we will be building and placing on a roof here in Melbourne. This is no easy feat, and our team is working incredibly hard to actually launch this and launch it next year. And that will finalise our Acrux-2 goal, and hopefully we can move to Acrux-3. Cool. So I suggest that anyone interested to interact with our social media and come and have a chat to me after this presentation. And I'll now pass to the next speaker. Thank you.
Hello. Oh gosh, that was too close. All right, cool. Good afternoon, everyone. Slides. Cool. It's a pleasure to be here today at the Space Convention Center as we gather to celebrate the innovations and advancements in student-led innovations in technology in the University of Melbourne. My name is Jared. I'm honored to represent the University of Melbourne, or as we like to call it, URT for short. We are a student-led engineering project team that's been pushing the boundaries of what's possible with extraterrestrial exploration, lunar research, and lunar settlements. So, before I dive into our work, I just want to thank the University of Melbourne and the event staff of Innovation Week for making this event happen. It's an incredible opportunity for us to share our passions, learn from one another, and cultivate this community of innovators and explorers. Without your hard work and dedication, none of this would be possible. So thank you guys. All right, so founded in 2021 in the midst of, 2020 in the midst of COVID, similar with Ares, the UniMelb Rover Team was born out of a passion for space exploration and a desire to apply our engineering skills to real-life challenges. We are a diverse team of undergraduates and postgraduates consisting of various disciplines, such as mechanical engineering, electrical engineering, software, chemical engineering, physics, and so on. And we're constantly working every single day towards a common goal, which is designing, building, and testing rovers that could one day explore the harshest environments of our solar system, which you can see one over there, which is our 2023 iteration that went to our competition in Adelaide. So one of our key aspects of our work is, of course, innovation. We constantly are seeking new ways to improve our designs, whether it be through advanced systems design, more efficient power delivery, novel approaches to problem solving, and so on. Our team consists of numerous multidisciplinary sub-teams that work in tandem to effectively integrate complex systems that form both our rover payload and our platform. Right, so our focus is on really developing interplanetary rovers capable of navigating and operating in conditions similar to those found on the moon. These rovers are not just theoretical designs, as you guys can see. They are practical, functional machines that we built by hand. And we've had the opportunity to test them in real-world competition environments. And I'm proud to say that in our first year of competing, we achieved second place in the Australian Rover Challenge and achieved third place in the following year, which is the rover you see over there. We're now setting our sights even higher as we plan to compete in the prestigious URC, the University Rover Challenge, held in Utah, America. But our journey really isn't just about the competition. It's about learning, it's about growing, and contributing to the student experience here in the university. Our team members have developed hands-on skills that go far beyond what they learn in the classroom. Skills that will prepare them for careers and industries ranging from aerospace to robotics, or whatever we put our minds to. We've also had the privilege of working and collaborating with multiple industry partners and sponsors who have supported us with their expertise, helping us convert our very ambitious ideas into reality. Looking ahead, we are really excited about the future of the rover team. We're eager to pursue the limits of what's possible, to explore new challenges, and to continue to evolve this and contribute this ever-evolving space of space exploration. We believe that the skills that we're developing and the knowledge that we're gaining will cultivate the next generation of engineers and space explorers. And we're thrilled to be part of this journey. We'll be thrilled to be part of their journey. Thank you for your time. And once again, heartfelt thanks to the University of Melbourne and event staff of Innovation Week for making this possible. Here's a slide full of our social media links, our Facebook, Instagram, and LinkedIn. So check us out there when you can. And yeah, thank you.